Hey all, this is Gayatri. I'm going to now teach about motion in a plane chapter. The topics I'm going to cover in this section is horizontal projectile as well as the oblique projectile motion. Further, if time has happened, I'm going to cover the topic like a liver boson and rain umbrella concept. That these two concepts becomes under relative velocity, and further we can see about circular motion. These topics we can see, but first we can focus on horizontal projectile and oblique projectile. What is meant by projectile? Projectile motion takes place with initial velocity. What I'm saying is the projectile is a motion. It is a motion when an object you're throwing from any point of any pointer. It may if you are throwing an object from a horizontal direction, the projectile we can say with some initial velocity, the projectile we can say it as some horizontal projectile. If you are projecting an object from the ground level and the path the object it follow and the motion the object take, we can say as the that type of projectile as a projectile, or we can say it as oblique projectile. In oblique projectile, we are going to cover the topics like equation of motion, range, time of flight, and velocity. These are the top concept we are going to see in oblique projectile. First, we are moving out to projectile motion. Projectile motion consider a body projectile with some initial velocity u, making an angle theta, okay, with horizontal direction. This I'm considering this as an initial velocity u. The initial velocity u can be resolved into two components, u cos theta and u sin theta. The components u cos theta I'm taking is an x direction, and the component term u sin theta I'm taking it at the y direction. Along vertical I'm taking the component u cos theta I'm taking on horizontal direction. In horizontal direction there is no acceleration you can see, which means the horizontal velocity remain constant in anywhere of the projectile. Okay, it does not depend upon the gravity, but the vertical direction. If you consider horizontal direction, there is no acceleration. You may ask a question now. How you can say there is no horizontal direction? There is no acceleration. See, basic concept of vector. This is a vector we can denote. Okay, the length represents the magnitude of the vector, and the arrow represents the direction of the vector. If we see that the horizontal direction, the length remains same and the arrow remains same. So we can conclude from this is itself that there is no change in horizontal direction, the velocity component. But if you consider a vertical direction, here you can see that moving upwards. Here initial velocity you can take it as u sin theta. Okay, I'm in a repressing on black color. Can take it. In every point of a projectile, you may see that this vector getting little bit down. At highest point, there is no component of u sin theta. Only the component of a projectile may be u cos theta. So from that we can conclude that the vertical component is depend upon gravity. You may consider u sin theta here, but in some point here you may say that velocity at the point is, let's say this point is C. Velocity at point C you can consider as u minus g. You may ask now, what is u here? U is initial velocity at a y component. Okay, initial velocity at y component. What is the initial velocity at y component? Initial velocity at y component is equal to u sin theta. But the initial velocity at y component at c depends upon u y minus gt. So it depends upon gravity. Have to consider initial velocity at y component at c depends upon initial velocity at y component minus gt. U y equal to u sin theta. U sin theta is the initial velocity at y component. See, as you can see that the final velocity at y component depends upon gravity. So the final velocity may change according to gravity level. Here you can see that more gravity, here the highest point, the gravity vary depends upon the height. So the vertical components also, vertical component of the velocity also may vary depend upon height. What are the topics we are going to cover in projectile is equation of projectile, range, time of flight, and velocity. These are the topic we are going to cover in projectile, and some of the concept too, that we will see now for the section. Okay, and equation of the projectile. Equation of the projectile simply represents this equation. You have to consider this equation. This big equation is the equation of the projectile. It seems to be big, but not that much. Okay, here you have to consider one thing. What does the equation of projectile represent? Y equal to u sin theta x divided by u cos theta minus 1 by 2 g x divided by u cos theta whole square. This is the equation of the projectile. But here we are representing is at y. We are considering the vertical displacement. This is the equation of projectile. If anybody asking what is the distance it will covered in this point, like this we are like this question may be asked from something, have to say that this is the equation. Okay, you may ask now from where this equation comes. Okay, if you consider, as I said before, there is no change in there is no acceleration. There is no acceleration. What you can say, the from conclude from that, there is no change in velocity at a horizontal direction. Okay, as you know that let's say final velocity at the x direction is vx. This is the final velocity at x direction. Final velocity at a horizontal direction or x direction or x axis, I can say horizontal direction, and ux be the initial velocity. Okay, at a horizontal direction. Vx equal to ux equal to simply u cos theta. There is no change, as I said before. As there is no change in velocity, there is no acceleration along its direction. Okay, the one the motion in the vertical direction is same with the body thrown upwards with initial velocity. Okay, see, like if you consider a body is thrown upwards within some initial velocity and with the acceleration g. From vertical, we have to consider, see, when the direction of the g depends upon the direction of the gravity. What I am saying was, if you are throwing an object upwards, here is the object. If you are throwing the object upwards, okay, any object with some initial velocity. If anybody asks what is the acceleration of the object, you simply say that a equal to minus t. Why we have to consider a equal to minus t? You are throwing the object here upwards. The direction of the velocity is this direction, but the acceleration acting on the object in this direction. Velocity direction this and acceleration acting on downwards. So can consider if acceleration and velocity are in same direction, then only we have to take it as a equal to g. If the acceleration and velocity in a opposite direction, then you have to consider acceleration as a minus g. Yeah, so I am taking acceleration as minus g. As I said before, there is no component of acceleration as along horizontal direction. Let we go on and equation. We take the equation x equal to ut plus half at square. This is the equation of motion. One of the equation of the motion. Okay. In this x we represent the y, and u here represent the initial velocity along y direction, and a represent the initial velocity acceleration. Okay, a represent the acceleration along y direction. As I said before, acceleration along y direction is equal to minus g. Okay, and t represent t equal to x divided by u cos theta. Where the t came from, you can ask me now. As I said before, velocity remained constant, and the distance traveled by the body in a time t, we take it as x. X is the distance traveled by the object in a particular time t in a horizontal direction. Distance traveled by the body in a horizontal direction in time. Let's take time this t. Distance formula is nothing but distance equal to velocity into time. Na? or we can say particularly we can correctly we can say that the displacement in time, but you can say this distance equal displacement in time, or displacement equal to velocity equal to time. Yes, the body moving in the same direction in a straight line, distance is equal to displacement. There is no distance displacement variation if a body moving in a straight line. I consider the body is projecting up, but the velocity in the straight line direction, there is no change in distance as well as displacement. Okay, can say velocity as I consider u cos theta, the time t, x is the distance. We can take the time as x divided by u cos theta. This is the time t. Here in this equation, y equal to u sin theta x u cos theta minus 1 by 2 g x divided by u cos theta whole square. In this equation, you can note that something. Okay, this is u y term, initial velocity to y direction, and this is the nothing but displacement along y direction, and this is nothing but t. And as I said before, this minus gt represent the acceleration along y, and as I said before, x divided by u cos theta represent the t square. Okay, here we can conclude that s equal to um into t minus 1 by 2 ay plus 1 by 2 a by t square. Here ay represent minus g. How to consider this is the equation of the projectile. Let's say simplify this equation further to take some of the models of the equation. You can consider this equation as y. In simple terms, we can consider this equation as y equal to ax minus bx square. What is ax minus bx square? What is this equation represent? See, this actually the equation is a parabola. You consider this is a parabola in a projectile. Y is a function of x square. This is a constant term, you negate that. Y is a function of x square. So this is the equation of a parabola. In equation of a parabola, in the projectile equation, what does A represent here and B represent here? A represent tan theta and B represent g by 2 u square cos square theta. This is B represent. A represent tan theta and B represent g by 2 u square cos square theta. These two representation of A and B. Why I have to consider this like this means, if another form of the equation of projectile, maybe say this the equation 1, this may be first equation, this may be the first equation. Another form we can take it as some tan theta x minus g divided by u square cos square theta x square. This is another form of the equation of the projectile. Have to consider this also. In a exam, there is a given there are many options. Select the equation of projectile from there. They may give this or they may give this equation, or say this equation. Have to consider any two of the equation. Okay. Another topic we are going to see right now is range. What does mean by range? If some another point we have to consider is, if anybody asks what is the trajectory followed by the projectile, is the trajectory nothing but the path followed by the projectile, or trajectory, or any word is the same only. Okay, trajectory followed by the projectile, trajectory or path followed by projectile equal to parabola. This you have to consider. The trajectory followed by the projectile is a parabola. Okay. Now we are going to see about a range. What is mid range? Now we are going to see. Range is the horizontal distance between the point of projection, and range is nothing but the horizontal distance between the point of projection and the point where the object reaches the ground. Okay. As I said before, you can consider in this equation itself, this is the range. The x distance we are considering This distance between the point of projection and the ground level where the object hits the ground is known as a range. That equation, that derivation of the equation we have to going to see now. Okay. Range. In range, you have to consider two sets of they say two concepts you have to consider in a range. Range, as I said before, distance between point of projection and the point which it hits the ground. This is the distance. Okay, range is nothing but the distance between the point of projection and the point when it here hits the ground. You can see that. You can say like that. In a range concept, you have to consider two important things, as I said before. One thing is there is no vertical velocity in there is no vertical velocity. As we consider a horizontal direction, why you have to consider vertical velocity? There is no vertical displacement. There is no vertical direction. No vertical velocity. Okay, but there is only one. What is the horizontal velocity? Horizontal velocity, as I said before, it remains constant and it is equal to Vx equal to u cos theta. This is the horizontal velocity. Okay, but and then move down again, reach the ground distance. See the object projecting from here and it going up the distance and it is moving down and reaching the distance here. Okay, the point of projection A and the where the point it hits the ground, let's take it as B, as I said already before. This taking this distance as a x. This x equal to the range. Okay, in equation of projectile, as I said before, we are considering x na. This is the range, nothing but a range. Okay, in the range concept, as I said before, there is no vertical velocity. As there is no, why there is no vertical velocity? There is no vertical displacement. Here in equation of projectile, this is nothing but vertical displacement. Y is nothing but what? Vertical displacement. This is nothing but what? Vertical displacement. So there is no vertical displacement. We can say y equal to 0. As y equal to 0, we can consider this as 0 equal to u sine theta minus or u sine y equal to u sine theta. You can take it the equation as a tan theta equation, that may be helpful, or you can take this equation also. X divided by u cos theta minus 1 by 2 g x divided by u cos theta whole square. Okay, if we simplify this equation, we can as I said before, x equal to, or if we simplify this equation, we may get equation like this: 2u square cos square theta divided by g into sin theta by cos theta. Like this, you may get the equation. If you simplify further this equation, you can get like r equal to 2u square g sin theta cos theta. You know that u sin theta cos theta, sin to theta is nothing but what? Sin to theta equal to 2 sin theta cos theta. This is the equation of sin theta, sin to theta equation. So we are writing u square sin 2 theta divided by g as a r. This is the range. Here theta represent what? Theta represent angle of projection with the angle of projection with the what? Horizontal level. This with the horizontal level. Sometimes they will give the equation as what is the theta represent sometimes they give angle of projection as a vertical level. You have to consider this angle of projection at the horizontal level. In question sometimes they will give angle of projection as a vertical level also. Okay, horizontal level. That's it. This is the range. Another topic we are going to cover in this section is time of flight. You can solve range on basis of velocity too, but we are solving on basis of distance, displacement, as I said before. Time of flight. Time of flight is nothing but the time taken by the projectile from the point of first to when it reaches the ground is known as time of flight, or the time followed by the projectile. Anything we can say. Time of projectile. Time the projectile when it is in air. Simply we can say when it is in air. Okay. In time of fragile concept, as I said before, if the time of our upward journey is st at highest point, we know the highest point what is equal to 0 at highest point, vy equal to 0 at the highest point. Highest point vy equal to 0 na? Vy equal to 0, we can take that. See, one concept is if the projectile the time here that here what the time of the projectile we consider is t. Here also t only. Here also t only. Okay. The t represent here also. If if here time equal to 0, in the highest point it will take a time t, and lowest point also 0. Say why lowest point also sin 0? As I said before, the time which in a year we consider as the time of flight. 0 from a point of projection to the highest point, it's take time t na. Highest point to the point of when it reach the ground, it takes some time t. Okay, the total time of flight we have to consider. Heat here represents something. If we can say that equation of projectile y equal to u sine theta minus dt. If we consider this equation, a t represent what? This is the matter. A t represent nothing but that time taken by object to cover half of the half of maximum height, or we can say to cover the half of the distance of the projectile. We can say like that also. Distance of projectile. Anything we can say, or the point of projection to this time is known as time t. Okay. Now we may resolve this as I said before. At the highest point, vy equal to 0. We can consider u sine theta equal to gt. T as the u sine theta by g. T as u sine theta by g. We can consider time of flight represented by the simple capital T. Here t represent, as I said before, the time taken by the object to cover the half of the distance, or we can say to cover the maximum height. This is the time taken by the projectile to cover the maximum height. Here time of flight represent capital T. So capital T equal to 2t, you can simply say. Like time can be additive, na? Time cannot be negative. Time can be additive. So here is taking time na. For half of the distance is take time t. Another half of the distance we can take the time small t. So total time of flight we can consider t plus t 2t. So time of flight equal to 2u sine theta by g. This is the time of flight. Okay. As I said before, there is something trick we can see. Okay, after velocity concept, I will say some of the tricks and some of the kinetic energy and some of the equations, so that it may be simple for you. Okay, then we are going to see about a velocity concept. Velocity concept is nothing, but we have to see. Okay, as I said before, in a projectile, it is drawing with velocity some u, making an angle theta with a horizontal, and this component is u sine theta, and this component is u cos theta. At the highest point, the component remains same u cos theta, but highest point, remember one thing, highest point there is no vertical component. Vertical component is 0, and lowest point is sum of the component. Okay. At the high, you see that if we take any point here, the component of the velocity will be let's say v here v. This is not initial velocity, and vy this is vy direction, and vx direction. Vx remains same as I said before. As I already said that vx will remain same anywhere. This component where I said now vx will be remain same anywhere in this projectile. Okay, here I said now this point is important. Vertical component, final velocity term, horizontal component term, same as the initial velocity at a horizontal component term, that is equal to u cos theta. This is vy nothing but you can consider vy as some, you know this equation, v equal to u plus at. This is one of the equation of the motions. No, in this equations, as I said before, this project is the acceleration along y direction is only be there. There is no acceleration along x direction. So I considering that velocity at y direction, velocity initial velocity at y direction, acceleration at y direction. Acceleration at y direction we can say that minus g. As I said before, there are same equation, same basic you have to consider as the equation of the motion. And that in that equation of the motion, what are the concept in range? Okay, if you consider range if you have to take y equal to 0, these are the points you have to consider there. Okay, and if you see ay equal to 0, ay means what? Acceleration along y direction is a 0. Sorry, acceleration along x direction is 0, acceleration along y direction equal to minus g. If we substitute this in this equation, vy equal to uy you already know, uy is nothing but u sin theta. Uy is u sin theta. As I said before, uy nothing but what? Uy is nothing but u sin theta. Here I said na, that means u sin theta, and ay nothing but minus g. This is equation at a time t. Okay, here vy nothing but u sin theta minus dt. Okay, so at time t, vertical component of the velocity, if anybody asks, this is vertical component of the velocity at time t. This is nothing but what? Vertical component of velocity at time t. The main concept you have to consider is uy is nothing but u sin theta, and a is nothing but minus g. Since the acceleration velocity is upward and the acceleration is downward, we are considering minus sign here. And final velocity at vertical direction. This is the final velocity at vertical direction. Since the acceleration is x direction is 0, there is no need to consider final velocity at x direction. Why final velocity why there is no concern means final velocity at x direction and initial velocity at x direction all remain same, that is equal to u cos theta. Okay. Then we are going to see about some of the concept in projectile. In the I said you before that I said you on equation y equal to ax minus bx square. In this equation there is one thing to happen. I know this is clear to you. Y equal to ax minus bx square. Now it's okay. It's clear. Okay. Here a represent nothing but a is tan theta, and b represent, as I said before, g divided by u square or square theta. Okay, this is the equation. I mean, this is the equation of the projectile. We can simply say this equation as like this. In this we can see some of the concepts like what is the if there's someone asks you what is the range is nothing but a by b. Range is nothing but what? A by b. How I say a by b? A by b is a what tan theta divided by b what g by u square cos square theta. This is not, we can tan theta we can represent sin theta by cos theta divided by g. The two we can go up to and u squared cos square theta. Actually, this two u square cos square theta also will move up. You can say that like sin theta by cos theta divided by g. We can take this 2 u square cos square theta. This cos theta and this cos theta cancel, and u square g. You see here sin theta cos theta. This u sin theta cos theta we can represent as sin 2 theta u square g. It will simply represents u square sin 2 theta by g. This is a range. Okay. Simply we can say that a by b. Easy na? Another we can going to say at another concept, time of flight. Time of flight. Simply we can represent t as a square root of a into a square root of 2 divided by bg. This is 2. Okay. Here I will write in a orderly way. Range equal to a by b, and time of flight equal to a into square root of 2 divided by bg. And you consider maximum height formula. Oh, maximum height we are not going to see now. You see some of the examples of maximum height. Okay, initial velocity. Initial velocity we can represent it as square root of g 1 plus a squared divided by 2b. Whole square root you have to consider. And maximum height it is a square by 4b. Now we are going to see about maximum height. I left the topic before. Come, we are going to see about maximum height. Maximum height maximum height. Maximum height, as I already said, there is no what velocity, there is no vertical velocity component at a maximum height. As I said before, now there is no vertical component at highest point. This is the highest point. See, this it is the height maximum. Simply h or anything h maximum. Okay, in this highest point, only the component of velocity is u cos theta. There is no Vy equal to 0 at the highest point. You have to remember this. Vy equal to 0 at the highest point. As Vi equal to 0, you can consider Vi equal to 0. Okay, Vy equal to 0 at the highest point. Na? So Vi equal to 0 and y equal to h. Where you have to consider y. Y is nothing but what? Y equal to u sin theta g x divided by u cos theta minus 1 by 2 g x divided by u cos theta the whole square. This is y. In this we have to consider this as a 0. I mean Vy equal to 0. Vy is not what? U sin theta Vy minus dt. Na? Vy 0 means what we can write? U sin theta as u sin theta equal to gt. As we know that T equal to what? X divided by u cos theta. This I said before itself. T equal to x divided by u sin u cos theta. You know that t equal to x divided by u cos theta. So if we consider u sin theta equal to gt, g into x divided by u cos theta. We can take it as like that, u sin theta. If you substitute this in equation of the projectile y equal to u sin theta u sin theta x divided by u cos theta minus 1 by 2 g x divided by u cos theta the whole square. For in place of u sin theta, you can substitute x divided by u cos theta whole square, or you may take this equation as for maximum height we have to take this substitute u sin theta here. You may get a h equal to something like u square sin square theta by 2g. This is the maximum height formula. Okay, this is the formula for maximum height max or h max. You can say h max is nothing but what? Maximum height reached by the projectile. This is known as a h max. Okay, this only we are considering this a square by 4b. In simple terms, we are saying that a square by 4b. Now we are going to see the concepts like some of these main concept. What is mean by h max? We are in some of this equation they are saying if range is same, we can consider the h max as maximum height. This is maximum height reached by the projectile. Maximum height reached by the projectile equal to maximum height reached by the projectile equal to r max by 2. What do you mean by r max by 2? What does this equation mean? Nothing but see r equal to u square sine 2 theta by g. Na? For h max, what is the equation? H max, as I said before, u square sine square theta by, okay, this we can take as height. Okay, what is the height? Maximum height reached by the projectile. Maximum height, okay, 2g. If we consider for range should be maximum, this 2 theta should be maximum, right? So 2 theta should be equal to, then what is the value of maximum value of sine value? Maximum sine value is 1. Sine 2 theta equal to 1. Since for range to be maximum, range directly proportional to sine 2 theta. Sorry, range maximum directly proportional to sine 2 theta. This should be maximum. This value should also be maximum. So sine 2 theta will be maximum when this is equal to 1. So 2 theta equal to 90 degree. So theta equal to 45 degree. Okay. If theta equal to 45 degree, R will be maximum. That will be equal to u squared by g. If we consider here maximum height. Maximum height we can consider h because take it as a h itself. Maximum value of maximum height we have to say, so that we are considering h max, which means when the value of h is maximum. Okay, h simply represent u square sine theta sine square theta by g 2g. When the value of h is maximum is this, since height directly proportional to sine square theta, if sine square theta is maximum, height also maximum. So sine theta equal to 1. So theta equal to what? 90 degree. Na? 90 degree. Na? If we consider height max, that is simply u square by 2g. Simply what? U square by 2g. If you see, if you compare this two equation, if you come to know that u square by 2 g nothing but r max. So we can substitute here as h max equal to r max by, this is one sort of equation. How many equations say this? Equation of motion, motion and then you may consider ample of equation. Have to remember that in mind. That's this also one sort of equation. Okay, this equation is important. This equation, this equation, this equation, and this equation too. H max equation too also important. Now we are going to consider some of this topic, like if what if happen if range is same, and what if what the highest potential energy at the highest point of, these are the topics we are going to cover now. Okay, if I think you are taking notes in meanwhile, because there are too much of concept here. Okay, if range is same, what will happen if range is same? When will the range is same? Range is same when there is so much of points. Theta 1 equal to theta, what I will say what is theta 1 and what is theta 2, and theta 2 equal to 90 minus theta. What you came to know about these 2 points? Nothing but, see, theta 90 minus theta, these are complementary angles. When the projectile is drawn with the complementary angles, then the range should be same. What I'm saying is, if consider this as this projectile is coming with a pointer 60 degree, and some other point, some other boy projecting it with a 30 degree. Okay, this take it as 30 degree, some other boy projecting with that angle 30 degree, then the range will be same for 60 and 30, because as it is a complementary angle. If theta 1 is equal to 60 and theta 2 equal to 30, this two, if one by projecting with angle 60 and another person projecting with angle 30, since these two are complementary angles, the projectile follow the path, and the object will fall in the same distance. Okay, at the same distance for the for the two persons also. So these are the complementary angles. If this happen, complementary angles are same, there are, we can say that there is so much of thing have to, I'm giving points. If derivation has happened, derivation going on a brief, I'm giving a brief derivation. If you want derivation, it will go more thing. There is no need of that and all. For a neat level J level, we can consider this one. T1 is the time of flight uh, for a ball, say uh, the boy projecting with some 60-degree angle, and T2 is the time of projectile, the boy projecting with angle 30 degree. If these two happen, T1 by T2 is nothing but tan theta, and H1 by H2. H1 is nothing but the height max reached by with the projector by angle 30 degree, and the height max reached by the projector with angle 60 degree. That is equal to what? This is equal to tan square theta. And there are many of the examples. And third, cancel H1 into H2 equal to R square by 16. In terms of range, they are asking na r square by 16. If projectile is projected with the two complementary angles, that height 1 be h1 be the height, and h2 be another h2 be the projected with the maximum height reached by the projectile when projected with an angle 60 degree, and or is the range they gave in the they gave in the question. And what is the relation between these three they are asking us? This is the relation how to consider. This is, see here, H1 H2 H1 is nothing but what? Maximum height reached by the projectile when the projectile is moved by the thrown by the angle projected with the angle 30 degree. And H2 is nothing but a maximum height reached by the projectile when it is projected by an angle 60 degree. Since these two are complementary angle, if they gave a range, you have to consider range R. And what is the relation they are asking means, if you have to consider this relation as some this one relation only. Okay, and we are going to see another important formula, like if what happened T1 into T2. You see, T1 is nothing but a time of flight, of a projectile with an angle of an object projected with an angle with an my data projection with an angle 30 degree. T2 is the time of flight of an object projected with an angle 60 degree. H1 is the maximum height. If we consider that H1 is the maximum height reached by the projector at an angle 30 degree, and H2 is the maximum height of the projector at an angle 60 degree. Okay. Uh, the two equation we are going to now consider as a T1 by T1 into T2. If they ask what is the product of the projectile when it is drawn from the complementary angle, what is the product of the product of the time of time of flight of the projectile when it is drawn with an angle complementary to each other. That is nothing but that is equal to 2 or 2 or by g. Here r represent nothing but what range. Okay, here 2 I have written 2. See, I am writing here also t1 into t2. T1 is the t2 nothing but what time. What is the product of the product of time of flight of the projectile when it is thrown at an angle at a complementary to each other? That is equal to nothing but what 2 r by g. And another one we have to consider is what is the sum of the maximum height of the projectile when it is thrown with an angle complementary to each other. Here now we are going to see about sum of the maximum height. Sum of the maximum height that will come by equations. Yeah, you can write it as u square by 2g. Okay, these are the concepts. They will come in a projectile motion. And another question is another if they ask about tan theta, here I said no tan theta. If they ask about tan theta equal to there are one another concept 4h by r. Here h represent the maximum height and rho represent the range. This is also one of the concept. Here he see h represent what maximum height. See, there is a two difference between maximum height and what is the maximum value of maximum height. If someone say about a h max, you in some book they represent h max as maximum height. In some book they represent the maximum value of a maximum height as a h max. Okay. Here I am taking that h equal to maximum height and h max as maximum value of maximum height. As I said before, maximum value of maximum height is 2 square by u square by 2g. And as I said before, h is equal to maximum height. Have to clarity in that. Here it represents the maximum height, not the maximum value of maximum height. Here all represent what range. Okay, the relation between a range and maximum height in terms of angle of projection they ask means we can take this relation. This is angle of projection. Okay, another one important relation there it will be that h equal to 1 by 8 I think so 1 by 8 gt square. Here t represent the time of flight. In terms of time of flight we can consider 1 by 8 gt square. Here t represent what time of flight. These are the concept I have covered in what motional plane under oblique projectile. Now we are going to see another concept, that is horizontal projectile. In horizontal projectile we are going to see about what is horizontal projectile and what are the things we are going to cover in horizontal projectile. Okay, horizontal projectile. Why you are thinking horizontal projectile? Horizontal projectile nothing but if you are going on some of a train. Okay, then let's say you are going in a Pontian Express. You are throwing some of the object from the train window. The object follows a path that trace the path that made by the object is known as a horizontal projectile. Okay, horizontal projectile is the path made by the object. Suppose the body is thrown horizontally from a point from from a point O. Let's say this a point as a O. Let's keep this point as a O. Okay. See, this point is O. From horizontal direction, if an object is thrown, the path traced by the object is known as what? Horizontal projectile. With the velocity, some velocity shall I am throwing with some velocity u. Okay, in horizontal direction, from some sort of height like this height, the height where from where I am throwing the object. The height from the ground level from where I am projecting the object in a horizontal direction is known as the height. Here, height is the from the where I'm projecting the object. And oblique projectile, the height is the maximum height reached by the projectile when it is projected from the ground. Here I'm the height I'm taking from a point of projection itself. In horizontal projectile, this is the main difference between oblique projectile and horizontal projectile. See, in horizontal projectile and oblique projectile, this is oblique projectile. In oblique projectile, here is the maximum height, and sorry, here is the point of projection, and this is the maximum height. But in a horizontal projectile, the point of projection as well as the maximum height is the same point. The maximum height, in maximum height only we are throwing the object. But here we are throwing the object from the where ground level. We are throwing the object. This is in a oblique projectile. Okay, wow. In oblique projectile, we are throwing the object from a ground level. Okay. Um, may here also we may consider that this is nothing but this is see, this is half of the what oblique projectile motion is nothing but the horizontal projectile. If you are throwing an object from here ground level, this is known as a oblique projectile. If you are throwing an object from a horizontal level from a maximum height, this is known as a horizontal projectile. In horizontal projectile motion also, the u cos theta term remain constant. As I said before, the reason I said before itself, may see before video, that reason I said before. Okay, and let's consider what are the going here. Also we can say that here we say that the range is nothing but the point of the height where the point where this is the point na A. So I take this point B and C. Here range we see that this is the point from where the where the object is projected from the height, that point from the ground level, that point to the point where it hits the ground is known as a range. Here in horizontal projection we say this is a range. In a projectile motion we say the point of projection and this is a range. Here we are not considering the point of projection, since point of projection is this is the point of projection from the ground level. We can say this is the point as a C. C is the point of projection from the ground level, and point of projection is this. Okay, there is a two difference between the point of projection in with respect to C. So there is a two difference between the point of projection. There is a two difference between the point of projection. Here the point of projection is from the ground level. Here the point of projection from a height term h. These are the two difference. Without any delay, we can go. As I said before, as a range is nothing but the horizontal distance. We can take it as x. See, distance equal to velocity into time na. Velocity into time na. Since horizontal velocity remains constant, u equal to x equal to u cos theta remain constant na. The horizontal component of the velocity remain constant. Let's take it as a u. Since why we are not considering here u cos theta, u sin theta na? We are not projecting the object with some angle here. Here in oblique projection, we are projecting the object with some angle, so we can resolve the initial velocity component as a two component. But here we are projecting the object with some initial velocity, but not with some angle and all. So yeah, we don't get any component of the initial velocity. In oblique projection, we can get the component of the initial velocity, but here we don't get the component of the initial velocity because here we are not throwing the object with some of the angle. Okay, so that we don't get any component of the initial velocity. We only get initial velocity. Okay, this velocity remains same as well as in all the positional direction. Okay, and horizontal displacement we can say as a u into x equal to what, u into t, this one. And if if we have to calculate the vertical displacement that we can take it at a y, y is vertical displacement, vertical displacement by. Consider y as a vertical displacement. Vertical displacement, since we are throwing an object with some initial velocity, and um, we are dropping. Okay, so acceleration along vertical displacement is In here, in this oblique projectile, we take acceleration along vertical displacement as minus g, but in horizontal projectile, we have to consider acceleration along vertical direction as the y means here acceleration is along, see, velocity is along downwards and acceleration also along downwards, so that acceleration is positive. Here velocity is upward, acceleration due to gravity is downward, so the acceleration is negative. This is the two major concept, key concept between horizontal pressure and oblique pressure. Why we have to consider minus g, why we have to consider the positive sign, where we have to consider positive and negative. These are two concepts you have to clear. This is our vector. Vector you have to consider direction also. Not only the magnitude, you have to consider direction also. Here the acceleration is upward and velocity is upward and acceleration is downward. So these are two in different direction, so opposite direction. So we can consider the same minus. But here velocity also in a downward direction. Okay, almost downward, and the acceleration due to gravity also downward, so we can take a sign as a positive sign. Okay, acceleration along y direction is g, so we can say vertical displacement, velocity at vertical displacement equal to ay here into ay into nothing but g into t, vy equal to gt. Okay, this is one of the equation, and resultant velocity you have to consider, and resultant displacement also you have to consider. As I said before, resultant displacement, since there is no component of velocity along a y direction, so x equal to ut plus half at square. If we consider this equation of at square, if we consider this equation of motion, we may see that there is no component of velocity along what direction? Y direction. Only the x direction there is the velocity, component of velocity. There is no component of velocity along y direction. So vertical displacement along y direction y equal to 1 by 2 a y t square. Here y equal to 1 by 2 g t square. This is the equation of vertical displacement of the horizontal projectile. This is the second equation. Same. And the resultant velocity you have to consider here, and we have to consider this x nothing represent what? You may think of what is meant by x. This x nothing what? Range. Range is represented by the symbol what? X. In this we can take from time of flight. Time of flight here you may see that I am said that angle of position from the point of position to the maximum height that I said before, the time is t, and here also t, the total time of flight b to t. But here the time of flight is t1. Okay, we can say take it as a capital T. Capital T is a time of a flight. You may consider this equation. This equation is in parabola equation, kx square y equal to kx square. Since this is also a parabola, while the trajectory also, trajectory the x means trajectory or path is parabola. Okay, and we are going to see about velocity component. Velocity component in this equation. Time of flight. See, time of flight here, we, it will follow that nothing but if we take this equation, time of flight is what? Here y represent time of flight, time taken by the object from maximum height to this. This is the time of flight. If you substitute this equation and take this equation, y have to be h max. Since time of flight is nothing but time taken by the object, taken by object from maximum height, to ground level, ground where it is hitting. This is the time of flight. Since the time where is sitting, we have to consider y is equal to h, and t as a total time of flight. Capital T is nothing but total time of flight. And g is g1d. If you take this equation, h equal to 1 by 2 g t square. In this equation, we can get a 2h by g equal to square root of 2h by c equal to time of flight. This is the time of flight of horizontal projectile. This is one equation. And range we have to calculate now. Range, as I said already, x equal to u into t. So range, we can say that range is nothing but r equal to u into capital T. U is u only, T water, T equal to 2h by your g. This is the range of a horizontal projectile. What is the range of horizontal projectile? 2h by g, r equal to 2h by g. We see range, time of flight, and velocity of the horizontal projectile. We see na velocity of the horizontal projectile. You can see that as I said, no, Vx is u, and there is no after reaching the ground, there is some of the there is no change in Vx, and Vyb uy u plus 80. This is uy plus 8 80. This is the equation of motion. Uy equal to 0. There is no vertical component of a velocity in a initial velocity. So Vy equal to ay into t. Ay is nothing but gt. Okay, this is what general equation of a velocity they ask means square root of x square plus vy square. Since why we are writing like this, x component and x dash and y dash, or x axis and y axis, and what is the angle between x axis and y axis? 90 degree. If you are taking any two vectors, vector equation be like this, like say what does mean by vector equation, vector of ab like this, cancel like this, square root of a square plus b square plus 2ab cos theta. This theta is a 90 degree here. He theta is 90 degree means we are considering what if theta equal to 90, our vector sum of resultant vector will be what? A square plus b square. No, like this we are considering here. Don't think that always this formula is true. When the theta is equal to 90, since the vx is here, vy is here, that is two angle between these two is 90 degree. So that we are considering what? Vx square plus vy square. If you substitute in that vx square plus vy square square root of v, we can say that u square plus as I said already, what by equal to nothing but what? By equal to gt. By square we can consider as gt square. We can say like that also, or we can consider this equation too. Which equation? V square minus u square equal to ax na? 2as. This equation will be na? This equation also we can consider, or we can simply consider gt square. This also 520. If any time, if they ask velocity at any time, you have to consider this velocity, final velocity at any time. This is the final velocity at any time. If they ask in terms of h max, or if we consider this equation, take is this equation. If a projectile reach the ground, let us consider like this. So v square and u square will be 0. U square by first component 2 g h. H is the maximum height. In terms of maximum height I am writing. So this will be 0, and vy square equal to 2gh, and vy equal to square root of 2gh. This is a vy term. Okay, if we consider in velocity in terms of h max, final velocity equal to square root of vx square minus plus vy square. Vx square is nothing but u square plus vy square we can consider as 2gh. This is velocity in terms of h max. Maximum height. So this is horizontal projectile. There are so much of concept here also, but this concept is enough. So for horizontal projectile, and I said for vertical project and projectile motion also. These are the concepts we have covered in this session. I hope you enjoyed the session. Thank you.